Section 9 of National Geographic Magazine, Volume 1, Number 1. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Survey and Map of Massachusetts by Henry Gannett. The Geological Survey is engaged in making a map of the United States. This work was commenced as an adjunct to the geological work, and was rendered necessary by the fact that except in limited areas, no maps of the country on any but the smallest scales were in existence. While these maps are thus primarily made to aid in the geologic work and in the delineation of geologic results, they are being made of such a character as to meet all requirements which topographic maps on their scales should subserve. The work is being carried on in various parts of the country, and is being prosecuted on a considerable scale, the annual output being between 50,000 and 60,000 square miles of surveyed area. Commenced in 1882, the work has been extended over more than 300,000 square miles at the present time. Of this work, the Survey of Massachusetts forms a part. In some of its features, this survey was an experiment. It was the joint work of the state and the United States, and, so far as I know, was the first example of such joint work. In the summer of 1883, the U.S. Geological Survey commenced topographic work within the state, the scale adopted being very nearly 2 miles to an inch. Only a beginning was made during the season, and in the following winter the governor of the state recommended to the legislature that if practicable advantage be taken of the opportunity, and an arrangement for cooperation be made between the state and the Geological Survey, by which a map upon a larger scale and with a greater degree of detail might be obtained as a result of this survey. Accordingly, after some correspondence with the director of the U.S. Geological Survey, the legislature authorized the appointment of a commission with power to make an arrangement with the director of the Geological Survey looking toward the result above indicated, and appropriated $40,000, being half the estimated cost of the survey upon the larger scale, $10,000 of which was to be available the first year, and $15,000 in each of the 2 subsequent years. The following is the text of the bill, which is in many respects a model legislative document. Commonwealth of Massachusetts. Resolved to provide for the topographical survey and map of the Commonwealth. Chapter 72, 1884. Resolved, that the Governor, with the advice and consent of the Council, be, and is hereby authorized to appoint, a commission to consist of 3 citizens of the Commonwealth, qualified by education and experience in topographical science, to confer with the Director or Representative of the United States Geological Survey, and to accept its cooperation with this Commonwealth in the preparation and completion of a contour topographical survey and map of this Commonwealth hereby authorized to be made. Said commission shall serve without pay, but all their necessary expenses shall be approved by the Governor and Council, and paid out of the Treasury. This commission shall have power to arrange with the Director or Representative of the United States Geological Survey concerning this survey and map, its scale, method, execution, form, and all the details of the work in behalf of the Commonwealth, and may accept or reject the plans of the work presented by the United States Geological Survey. Said commission may expend in the prosecution of this work a sum equal to that which shall be expended therein by the United States Geological Survey, but not exceeding $10,000, during the year ending on the 1st day of June, 1885, and not to exceed the sum of $15,000 in any one year thereafter, and the total cost to the Commonwealth of the survey shall not exceed $40,000. In pursuance of this resolution, Governor Robinson appointed the following gentlemen as commissioners on the part of the state: General Francis A. Walker, President of the Massachusetts Institute of Technology; Mr. Henry L. Whiting, Assistant U.S. Coast and Geodetic Survey; and Professor N. S. Shaler of Harvard College. The Director of the Geological Survey, upon being notified of this action, laid before the Commissioners a proposition for a joint survey in the following terms. 1. It is proposed to make a topographic map of the State of Massachusetts, the expense of which shall be borne conjointly by the Geological Survey and the State of Massachusetts. 2. The Borden triangulation and the Coast and Geodetic Survey triangulation will be utilized as far as possible, and additional triangulation will be made to such extent as may be necessary. 3. The topographic work of the Coast and Geodetic Survey will be utilized as far as it extends. 4. The survey will be executed in a manner sufficiently elaborate to construct a topographic map on a scale of 1 to 62,500. 5. The topographic reliefs will be represented by contour lines with vertical intervals varying from 10 to 50 feet, as such intervals are adapted to local topography. 6. As sheets are completed from time to time, copies of the same will be transmitted to the Commission. 7. When the work is completed and engraved for the Geological Survey, the Commission or other state authorities may have, at the expense of the state, transfers from the copper plates, thus saving the state the cost of final engraving. 8. The survey will be prosecuted at the expense of the Geological Survey for the months of July, August, and September. During the last half of the month of September, the Commission shall examine the work executed up to that time, and if the results, methods, and rates of expenditure are satisfactory to the Commission, the expenses of the work for the month of October shall be borne by the State of Massachusetts, for the month of November by the Geological Survey, and the work thereafter shall continue to be paid alternately by months by the Geological Survey and the State of Massachusetts severally. But as the larger expense incident to the beginning of the work is imposed on the Geological Survey, at the close of the work the State of Massachusetts shall pay such additional amount as may be necessary to equalize the expenditures, provided that the total expenditure of the State of Massachusetts shall not exceed $40,000. And if the completion of the survey of the State of Massachusetts and the preparation of the necessary maps on the plan adopted by the survey shall exceed in amount $80,000, then such excess shall be wholly paid by the Geological Survey. The Commissioners suggested some minor amendments to this proposition, which were accepted, and under these provisions, work was commenced and carried forward continuously to its completion. The field work of the state was finished with the close of the season last fall, and the drawing of the maps is now substantially done. The work was done in the field with such accuracy and such degree of detail as to warrant the publication of the map upon a scale of 1 inch to a mile, or, what is practically the same thing, 1 to 62,500. The relief of the surface is represented by the contour lines, or lines of equal elevation above sea, traced at vertical intervals of 20 feet. These contour lines, which are becoming a common feature of modern maps, add an additional element. They express quantitatively the third dimension of the country, viz., the elevation. An inspection of such a map not only shows the horizontal location of points, but their vertical location as well. It gives the elevations of all parts of the country represented above the sea. The map represents all streams of magnitude sufficient to find place on the scale, and all bodies of water, as lakes, swamps, marshes, etc. In the matter of culture, in which definition is included all the works of man, it seemed desirable to represent only such as are of a relatively permanent nature, and to exclude temporary works, for the very apparent reason that if temporary works were included, the map would be not only a constant subject for revision, but even in the interval between the survey and the publication, the culture might change to a large extent, and the published map be correspondingly incorrect from the outset. In searching for a criterion which could be consistently followed in distinguishing between culture which should and should not be represented, it was found that by limiting the representation to that which may be denominated public culture, that is, that which has relation to communities as distinguished from individuals, a consistent line could be drawn. Adopting this criterion, the map contains all towns, cities, villages, post offices, in short, all settlements of any magnitude, all railroads and all roads, with the exception of such as are merely private ways, all public canals, tunnels, bridges, ferries, and dams. There were excluded under this ruling isolated houses, private roads, fences, and the various kinds of crops, etc. Forest areas are shown. Subsequently, however, in response to the urgent wish of the commissioners, the survey consented to locate the houses upon the maps, although in the engraving these have been omitted. The omission of all private culture leaves the maps very simple and easy to interpret. For convenience, the field work was done upon a larger scale than that upon which the maps were to be published, viz., a scale of 1 to 30,000, or a little more than double the publication scale. The map of the state as planned is comprised in 52 atlas sheets, each of which comprises 15 minutes of latitude and 15 minutes of longitude, and an area of about 225 square miles. These sheets upon the scale of publication are about 17.5 inches by 13 in dimensions. In 2 or 3 cases along the coast it seemed to be in the interest of economy to vary from this arrangement slightly in order to avoid the multiplication of sheets. Many of the sheets upon the borders of the state project over into other states, and in cases where the area lying without the state was small, the survey was extended beyond the limits of the state in order to complete the sheets. Every map is a sketch, which is corrected by the geometric location of a greater or less number of points. Assuming entire accuracy in the location of the points, that is, assuming that the errors of location of the points are not perceptible upon the map, the measure of accuracy of the map consists in the number of these geometric locations per unit of surface, per square inch, if you will, of the map. The greater the number of these locations, the greater the accuracy of the map, but however numerous they may be, the map itself is a sketch, the points located being simply mathematical points. Whatever method be employed for making these geometric locations, the sketching is substantially the same everywhere. The methods of making these locations must differ with the character of the country, as regards the amount and form of its relief, the prevalence of forests, and other circumstances. There are 2 general methods of making the geometric locations used in surveying, one by triangulation, the other by the measurement of a single direction and a distance, which is the method employed in traverse surveying. In practice, the 2 methods are often combined with one another. Both methods have been employed in Massachusetts. The fundamental basis of the work was the triangulation which had been carried over by the state by the U.S. Coast and Geodetic Survey. By this survey, points were located at wide intervals over the state. Besides this, there was executed between 1830 and 1840, at the expense of the state, a triangulation known as the Borden Survey. This located a much larger number of points, but less precisely. The Coast and Geodetic Survey kindly undertook the adjustment of this triangulation to an agreement with its own work, and as many of the lines were common to the 2 pieces of work, the locations made by the Borden Survey were by this adjustment greatly strengthened. Even after this work was done, however, there remained considerable areas which were destitute of located points, and it became necessary to supplement it. This was done in part by the Coast and Geodetic Survey, and in part by the Geological Survey. By these several agencies upwards of 500 points were made available for the use of the topographers. These are, in the main, well distributed, furnishing upon each sheet a sufficiency, while upon many the number is greatly in excess of the requirements. The work of location has been done in different parts of the state by different methods as seemed most applicable to the differing conditions of relief, forest covering, and culture. Throughout most of the western part of the state, the work was done entirely with a plane table, using the method of intersections as the means of location. Each plane table sheet comprised 1/2 of an atlas sheet, cut along a parallel of latitude. The plane tabler, starting with 3 or more locations upon his sheet, furnished by the triangulation, expanded over the sheet a graphic triangulation, locating thereby a considerable number of points before commencing detailed work. This was done as rapidly as possible, consistent with a high degree of precision. The reason for covering the sheet with the graphic triangulation beforehand lay in the necessity for locating a considerable number of points before the sheet had opportunity to become distorted by alternations or moisture and drying. This done, the plane tabler went on with his usual routine of work, locating minor points and sketching the topography and contours. The map was as far as possible completed upon the stations, with the country in view. Elevations were determined as the work progressed, with the vertical circle of the alidade, and minor differences of elevation between points whose height was known were measured by aneroid barometer. In this work several different forms of plane table have been employed. It was commenced with a large heavy movement, designed I believe by the Coast and Geodetic Survey. This however was found unnecessarily heavy and cumbersome, and it was discovered that the requisite degree of stability could be obtained with much less weight. For this plane table movement there was soon substituted another form in use in the Coast and Geodetic Survey, which is very much lighter. This was soon improved by taking off the slow motion in azimuth, which was found to be unnecessary, and the addition of more powerful clamps for the purposing of rendering it more stable. A more stable form, however, coupled with even less weight, was designed by Dr. W. D. Johnson of the USGS, and was immediately adopted. This is substantially a modification of the ball and socket movement. It consists of two cups of large size fitting closely to one another, and working within one another in such a way as to allow of the adjustment in level, and the clamping of the level adjustment independently of the azimuth movement, clamps for both level and azimuth adjustments being underneath the instrument. This form is extremely stable, admits of quick adjustment and leveling, and it has been from the time of its invention in general use in this state and elsewhere in the survey. In the undulating, forest-covered region in the southeastern part of the state, it was found impracticable to use economically the method of intersections, and resort was had to the traverse method of making locations. In this method, as is well known, one station is located from one another by the measurement of a distance and direction, the line of stations being connected at each end either upon stations in the triangulation or upon other lines, while from the stations in these traverse lines, points off the lines are located by intersections, if practicable, or by distance and direction measurement. For this kind of work, the plane table, at least such a plane table as is generally in use, is an inconvenient instrument. The plane table with the telescopic alidade is too cumbersome an instrument to be carried about and set up as frequently as is necessary in this work. Therefore, for this purpose, theodolites, fitted with stadia wires and stadia rods, have been used. Distances are measured by the angles subtended by the stadia wires upon the rod, whose divisions are of known length, while the directions are measured by the compass attached to the theodolite, and differences of elevation by spirit level and vertical angles. With this instrument, lines were run along all the roads and along the principal streams in this part of the state, and from these lines the country lying between them was located and sketched. In the northeastern and in much of the middle portion of the state, a mixed method of work was employed, the plane table being used for carrying on the intersection work whenever it could be done, while by traversing the roads their details which could not be obtained by the plane table in this region were reached. These traverses were plotted in the office and the maps drawn from notes and sketches made in the field. The degree of accuracy of the map depends upon the accuracy of the locations, their number, and the uniformity of their distribution. Of their accuracy it is only necessary to state that their errors are not sufficiently large to be appreciable upon the scale of the map. For instance, the scale being 1 inch to a mile, an error of 50 feet in the location of a point would be upon the map but 1/100th of an inch, a barely appreciable quantity, and it is of course easy to make the locations within this limit. Of the number of locations per unit of map surface, I shall give statistics drawn from the full experience of the survey in this state. The area surveyed by the method of intersections exclusively comprises 3,500 square miles, or about 2/5 of the state. In this area 3,123 stations were occupied with the plane table, or slightly less than 1 to a square mile, or, measured upon the map, 1 to a square inch. Besides these, 17,846 points were located in this area by intersections, making with the occupied stations a total of 20,969 locations within the area, or 6.2 horizontal locations per square inch. In the same area, the heights of 34,893 points were measured, being 10 per square inch. I am expressing these figures in terms of inches of the final map, because it is the map with which we are concerned. The area surveyed by the traverse method is 2,500 square miles. In this area 5,615 miles of traverse lines were run, being 2.2 linear inches per square inch of the map. In running these lines, 46,524 stations were made with the theodolite, being 8.3 per linear mile of traverse and 18.6 per square inch of map. The number of measurements of height was 92,561, being 37 to the square inch. The area surveyed by the mixed method comprised 3,000 square miles. In this 900 stations were made with the plane table, and from them 3,718 points were located by intersection, making altogether 4,618 points located with the plane table. In addition to this, 6,767 miles of traverse were run, being 2.2 linear miles per square mile of area. In these traverses, 31,708 instrumental stations were made, or 4.7 per linear mile, and 10.6 per square mile. The sum of the plane table stations, locations, and the traverse stations, which makes up the total of horizontal locations in this area, is 36,326, being a total of 12.1 points per square inch of map. The number of measurements of height in this area is 67,119, being 22.4 per square inch. It will be seen that the number of horizontal locations and of height measurements in the area traversed is much greater than in that surveyed by the intersection method, and it might be inferred that the former work is better controlled than the latter. I do not judge, however, that this is the case, owing to the fact that traverse stations are not of as much value for purposes of location as those by intersection. The latter are selected points. The former are not selected points, but on the contrary a large proportion of them are located simply for carrying forward the line, and are of no further service, and very few of them are such as would be fitted for the purpose of controlling areas. Within the area surveyed by traverse, nearly every mile of road has been run. With the exception of those in the cities, nearly every house and every church in the Commonwealth has been located either by intersection with the plane table or by traverse. The organization of the surveying parties has been of the simplest character. Plane table work has been carried on by one man with an assistant, the latter doing little more than attend the plane tabler and assist him in carrying the instruments. Each of these little plane table parties was furnished with a horse and buggy for transportation. The organization for traverse work has been equally simple, consisting of a traverse man and a rod man. As a horse and buggy would be an impediment in this work, this feature of the outfit has been omitted. In the mixed work, the traverse men have been under the immediate control of the plane tabler, so that their movements have been directed by him in detail. The average output per working day of the plane tabler has been for the whole survey 3.1 square miles, and of the traverse man 2.8 square miles, and, as the expenses of the former have been slightly greater than those of the latter, the cost per square mile of the two methods of work has been substantially the same. The average cost per square mile of the survey of the state has been a trifle less than $13. This includes the salaries of all men engaged upon the work during the field season, their traveling, subsistence, and all other expenses. the salaries of the men engaged in drawing the maps in the office, the cost of supervision and of disbursement, in short, all expenses of whatever character incurred in the production of the map. End of Section 9, and end of National Geographic Magazine, Volume 1, Number 1.